Let's talk about factors. Here are the characteristics of factors. Most importantly, factors are used to represent categorical data. Since we often have categorical data when we conduct statistical analysis, using factors is going to be a common practice. Factors are stored as integers with labels. Factors contain predefined values known as levels. And surprise, surprise, the class of a factor is factor. Let's look at creating factors and do so in a way to be of most use to us in statistical practice. Given the useful information that can be contained in an R factor, it's valuable to add that information when creating the factor and not just the data. Let's look at how to create factors without that information and then add it later, as well as how to add that information when creating a factor. We can create a factor with the factor function. So here I have a vector, and I'm going to use the factor function for that vector. In this particular example, we might have three groups, and so study condition is a categorical variable, which is why I'm creating a factor with it. Study outcome, on the other hand, is a quantitative variable, the outcome for each individual. So in this example, we have 12 individuals, 4 in each of 3 conditions. So let's create the condition factor. And then we have 12 scores, 1 for each individual that is in each of the 3 conditions. So let's create that outcome. Let's look at the characteristics of the study condition factor. You see here in the console window that it indicates these 3 integers and that these represent 3 levels, 1, 2, and 3. The attributes of study condition are the levels, 1, 2, 3, and the class, which is factor. Now note that even though the factor levels are stored as numerals, they're not numbers. We can't treat them like numbers. Let me try to get the mean of study condition. And it tells me argument is not numeric or logical, so I cannot get the mean of study condition. If I want to view the levels of a factor, I can use the levels function. So this will tell me 1, 2, 3, just like when we got the attributes. We can also use the level function to name the factor elements. So now let's look again at study condition. Now the levels are control, treatment 1, and treatment 2 instead of 1, 2, and 3, which makes a lot more sense in terms of keeping track of the various categories in our study. We could have done this at the time of creation with the labels argument. So here I'm creating factor. 1, 2, and 3 are the levels, but I'm going to name those control, treatment 1, and treatment 2. Let's suppose that our vector was not in order. Take a look at this example. So now I have someone from category 2, 2 people from category 1, 1 person from category 3, and so forth. What will happen when I label control, treatment 1, and treatment 2? The labels are still correct because they're assigned in numerical order. So the first level, number 1, will get assigned the first label, control, the second, treatment 1, and the third, treatment 2. We could switch the order if in fact we needed to do that. In this example, level 1 will be associated with treatment 1, level 2 with treatment 2, and level 3 with control. So now you can see that the number 2, category 2, was with treatment 2, and the category that was previously labeled 1 is now labeled treatment 1 because we had it in the first position here. The order of the labels matches the numerical order of the factor, but we could also change the order like this. Here I have 1, 2, and 3, and I'm going to put in the labels control treatment 1 and treatment 2, but I want the control group to be with level 3, the treatment 1 to be with level 2, and treatment 2 with level 1. Notice that the labels are assumed by the levels. Also notice that the order of the levels now matches the reordering that we've done. Here we see the levels, control, treatment 1, treatment 2, in the same order as our labels, not in the order of our levels. Suppose we want to change the control level to be placebo. We can treat the levels as a vector. So here I'm going to take levels, and I'm going to take for study condition the first level, which is now control, and change it to placebo. We can also label factors by naming them in our data vector. So here, instead of using 1, 2, and 3, I now have 2 people in low, 1 in high, 2 in medium, and then the final one in high. And so my levels now are high, low, and medium. Notice that the levels are in alphabetical order. Let's change that. Now my levels are in the correct order. And even though they're in the correct order, notice in the actual vector itself, we've not messed anything up. We have low, low, high, medium, medium, high. It's just that the levels now are assumed to go from low to medium to high. We could have done this at the time of creation. Here I'm going to put in those same values, but I'm going to put the levels in the order I want them to be in. Remember that numerical functions don't work with this. Let's try typing this in the console. Minimum dosage. That's an error. Minimum is not meaningful for factors. But wait a minute. There are 2 kinds of categorical variables, unordered and ordered, and it sure seems to me like low, medium, and high should be ordered. Dosages are ordered categorical variables. So if I take the minimum, there's something that tells me that should work. Here's how we can fix that. We can, when we put in dosage as a factor, use a new argument called ordered. Ordered is by default false. So when you don't put in the ordered argument, it assumes you have unordered factors. But now if I put it like this, ordered true, now I actually can get minimum dosage. It tells us low is the minimum, and also says the levels are low is less than medium, which is less than high. We can use the GL function to generate factors in a sequence, much like the sequence function will generate numeric sequences. Look at the following. This is going to generate 4 levels with 20 participants at each level, and the 4 levels are going to be condition A, B, C, and D, but we're going to have 20 in condition A, 20 condition B, 20 condition C, and 20 in condition D. Let's run it and look. This is actually quite long, but you get the idea that we have 20 condition A's, 20 condition B's, and so on. So when we create factors, the factor function is our common function for creating those factors. The levels function can be used to name those factor elements. The labels argument can be used to rename levels at the time of creation. The levels argument can be used to indicate the order of levels, and the ordered argument can be used to indicate that we have an ordered categorical variable. The GL function generates factor sequences.